In the given triangle, cos A equals 4 over 5. Without using a calculator, find the value of sine A, hence find the area of the triangle. So we have angle A, we have a side of 20 units and another side of 28 units. So given in the question is that cos A is equal to 4 over 5. So if we write out SOHCAHTOA, we can see that cos is A over H. So cos is equal to A over H. So the A must be 4 because the numerator is 4. So the A must be 4. So the adjacent must be 4. And the hypotenuse must be 5 because the denominator is 5. So the hypotenuse is 5 units. So I'm going to draw out this triangle. I'm going to label angle A. The hypotenuse is 5 units, as we said here. So the denominator is 5. So the hypotenuse is 5. And the adjacent is 4. So the adjacent is 4 units. So we can label the third side as x. So then we're going to use Pythagoras' theorem to find x. So we label our triangle ABC. C must be the longest side. C must be the hypotenuse. We write out the formula. C squared equals A squared plus B squared. So the C squared becomes 5 squared. That's from here. The A squared becomes 4 squared. That comes from here. And the B squared becomes X squared. That comes from here. So now we want to solve for X. So we get 25 is equal to 16 plus X squared. So the 16 comes over the equal sign and becomes minus 16. And 25 minus 16 is 9. So 9 is equal to X squared. So the square root of 9 is equal to X. So X is equal to 3 units. So we can replace that X now with 3. So we're asked to find the value of sine A. So SO gives us sine is equal to O over H, opposite over hypotenuse. So sine A, because that's the angle that we have here, is equal to the opposite, which is going to be 3, over the hypotenuse, which is going to be 5. So we have sine A is equal to 3 over 5. Hence, find the area of the triangle. So the area of the triangle formula is a half AB sine C. So we're going to relabel that capital A as capital C because we have sine C in our formula. So that must be lowercase c. Then I'm going to call this angle A, so that must be lowercase a. And angle B, so lowercase b. So we get a half times whatever the A is multiplied by whatever the B is, stuck onto sine C, so multiplied by sine C. So the A is 20 units, so that came from up here. The B is 28 units, so that came from here. And I'm replacing sine C with sine A because originally it was sine A. Originally it was angle A. And we're going to use what we worked out up here, sine A equals 3 over 5, down here. So I'm going to replace sine A with 3 over 5 in brackets because we worked out that sine A is equal to 3 over 5. And then I can just stick all of this into the calculator to get the area. So we get 168 square units. So the area of this triangle is 168 square units. RST is a triangular plot of land in which the length of RT is equal to 18 meters, the length of TS is equal to 23 meters, the area of the plot is 207 meters squared. Part 1, draw a rough sketch of this plot. So here's our rough sketch. So I've drawn my triangle, I've labelled it RT and S. I've labelled RT as 18 meters TS is 23 meters. I don't know what OR-S is. Part 2, find the angle OR-TS. So find this angle here. So I know that the area is 207 meters squared, so I'm going to use that to work this out. So I'm going to write out the area formula of area of a triangle. So triangle area is equal to half AB sine C. I replace area with 207 because I was told the area is 207 meters squared. And then I'm going to replace all of my letters in my formula with sets of brackets. Now, because I have a capital C in my formula, I'm going to relabel the angle that we're interested in, which is this angle here, as capital C. So therefore, the side opposite must be lowercase c. I'm going to relabel this as capital A. So the 18 meters is lowercase a. And I'm going to relabel OR as capital B. So the opposite side, 23 meters, is lowercase b. Then I sub into my formula. So lowercase a, I replace with 18. It's inside the brackets. Lowercase b, I replace with 23. That's inside the brackets. And then sine c, I'm just going to call sine x because that's ultimately what I'm looking for. You could leave it as sine c if you want and solve for c. So I'm going to bring down to 207 and then I'm going to put half times 18 times 23 into my calculator. I get 207 and stick on the sine x. I want to find x, get x on its own. So I need to divide by the number stuck in front of the sign. So that's 207. So I'm going to divide both sides by 207. And 207 divided by 207 gives me 1. So I have 1 is equal to sine x. When I do not know the angle, I use the inverse. So I have sine to the power minus 1, so I press shift and sine on my calculator. A bracket will open. I'm going to put 1 into the bracket and close the bracket. And it gives me 90 degrees. Therefore, the angle, OR-TS, is 90 degrees. Part 3. If the lengths of the sides of the plot are doubled, but the measure of the angle OR-TS remains unchanged, investigate if the area of the plot is also doubled. Explain your answer. So here's our original triangle, and we know that the area was 207 meters squared. So OR-T was 18 meters, TS was 23 meters. And we now know that this angle here is 90 degrees. The new triangle, I've labelled OR-T-S'. So if the original side OR-T was 18 meters, I'm going to double that, so multiply by 2 to get 36 meters. And if the original side TS was 23 meters, I'm going to double that, so multiply by 2 to get 46 meters. So I'm going to write out the formula for the area of a triangle. So triangle area is equal to half AB sine C. So I'm going to replace all the letters of brackets. I'm going to relabel this angle as capital C. So this side is lowercase c. I'll relabel this as capital A. So this is lowercase a. And I'll relabel this as capital B. So this is lowercase b. And then I sub into my formula. So a, lowercase a becomes 36. That came from here. Lowercase b becomes 46. That came from here. And the c becomes 90. Because we know already that this angle is 90. Into the calculator. And we get 828 units squared. And 828 is not double 207. 207 times 4 gives us 828. So when the sides are doubled, the area increases by a multiple of 4. A farmer wants to give a triangular plot of land to his daughter on which she can build a house. The plot is bounded on 2 sides by a hedge and a road. The hedge makes an angle of 78 degrees with the road. If the road frontage of the plot is 20 meters, how far along the hedge should the plot extend if the area of the plot is 1500 meters squared? Give your answer correct to the nearest meter. So I'm going to write out the area formula, half AB sine C. I'm going to label that angle 78 degrees as capital C. So this side is lowercase c. I'm going to label this as capital A, so the 20 meters is lowercase a. And I'm going to label this as capital B, so this is going to be lowercase b. So we know that the area is 1500 meters squared, so I'm going to replace area with 1500. I'm going to replace all of the letters in my formula with brackets. Then I'll sub into the brackets, lowercase a will become 20. And I'm going to label the lowercase b here as x, or you could leave it as b if you want and solve for b. So I'm going to put x into my brackets, and then sine c becomes sine 78. So bring down to 1500, and then half times 20, or half of 20, is 10. I'm going to hold off on sticking on the x because I'm just going to stick that on at the very end, because when we're multiplying, the order doesn't matter. So sine 78, that gives me 0.9781 to 4 decimal places, which is enough. And then I'm going to stick on my x. So I bring down to 1500. And then 10 times 0.9781 is 9.781. And then I'm going to stick on the x. And then I'm going to divide by what's stuck onto the x, which is 9.781. So divide both sides by that. So I have 1500 divided by 9.781. You stick that into the calculator. And I get 153.3585 is equal to x. And I want my answer correct to the nearest meter. So I get 153 meters. So this length here that we had originally labeled as lowercase b, this must be 153 meters to have an area of 1500 meters squared.